Hello everybody! In today's video lecture, you'll learn about free fall and practice how to calculate how far and how fast an object falls. In physics, the term free fall means, with the effect of air resistance ignored, an object can fall freely. That is, it can fall experiencing only acceleration due to gravity. We find that objects with small surface areas relative to their masses, such as a medicine ball, a basketball, or a golf ball, do in fact fall at the same rate, even though air resistance is present. So we don't need to go to the moon to experience free fall. We can still make useful approximations, ignoring the air resistance. We can consider free fall as a special case of motion with constant acceleration. Let's review our equations for constant acceleration. Here is the first equation. Displacement equals average velocity times the time. Please note that up until now, we consider the displacement delta x and the final position x as virtually the same because we considered the motion started from origin or 0, so x minus 0 is x still. But that is not always the case. So let's use the more proper version of delta x in our equations from now on. So here is the displacement equation with the average velocity plugged in, the velocity equation, another displacement equation, and the timeless equation. Now let's take a look at the case of free fall. How is free fall different from constant acceleration? This time, acceleration can take only one value, 9.8, and point only in one direction, down to the center of the Earth. So we call this acceleration g instead of a. G is 9.8 meters per second squared, or for simplicity purposes, we can round it to 10 meters per second squared. Since the acceleration due to gravity always points down and the traditional designation for down is negative, we will replace the a terms into negative g. Let's also change all x terms into y, since the motion is happening strictly in y-axis. So our new equations become displacement equation, velocity equation, second displacement equation, and the timeless equation. So please pause the video now to record these new information into your list of equations. Here is our first example problem. A rock is dropped from an 80-meter cliff. What is its velocity after 2 seconds? Let's start by having a list of given and unknown, and we can do that by drawing a diagram. So let this be a positive y-axis, this be the x-axis here. So this is our original position, 80 meter, and this is our final position, 0 meter, and our acceleration is negative g because downward direction is negative here. So I need to solve for the velocity after 2 seconds. Let's consult our list of equations here. And it seems like equation number 2, the velocity equation, is a good pick. V equal to V original minus GT. So I'll just have to use it. V equals V original minus GT. And the original velocity is 0 because it's just dropped from rest. Minus, let's use GS10 for simplicity purposes, and 2 seconds. So our final velocity in this case is going to be negative 20 meters per second. And the negative of the velocity means it's just simply pointing downward. So this is part A. And part B. What is its acceleration after 2 seconds? Well, it doesn't matter how many seconds it passed. Acceleration is always equal to g. So acceleration is still g, or you can call it negative g. And next part, part C, how long does it take to reach the ground? So I just need to solve for time now, and I'm checking my list. The first 3 equations have time in it. I can use any one of those, But equation 1 and 2 is not very useful to me at the moment because I don't know the final velocity. So it has two unknowns in this situation. But equation 3 is just perfect because I know what delta y is, original velocity, and I'm solving for time. So I want to use the displacement equation, the equation number 3. Delta y is equal to v original t minus 1/2 gt squared. Okay, delta y is, as you know, y minus y original, and v original is just 0, so this part is just going to go to 0, negative 1/2 tan times t squared. Okay, so y is 0, so 0 minus 80 is going to give me minus 80 equals negative 5 t squared. We can just get rid of the negative, but making both sides positive here. And 80 over 5 is going to give me 16. So t squared is 16. So this means time is 4 seconds. Yay! It takes 4 seconds for it to fall down. And now part D. What is the final velocity? Now at this stage I can use any of these equations because I know the time, I know the displacement, I know acceleration, I know everything. So to add some variety, let's use equation number 4, the timeless equation. So v squared is equal to v original squared minus 2g delta y. Now v squared is my unknown. V original is just nothing, 0, minus 2, 10, and as you see, delta y is negative 80. So that solves my problem. And this means v squared is equal to 1600, and v is equal to plus minus 40 then. There's no square root here. Plus minus 40. Well, I better use the negative sign for it because the velocity is still pointing downward. So my final answer is v is equal to negative 40 meter per second. Here we go. Here is another example problem. You may want to stop the video here and try this question on your own, and then you can check your answer with mine. I start by having a list of given and unknown, and this is my positive y and positive x-axis. The original position is unknown, the final position is 0, time is 3 seconds, acceleration is g. Since the downward direction is chosen as negative, acceleration is automatically negative g. Let me take a look at my list of equations again. I need to solve for original position, so I want to use the equation number 3 again. So delta y is equal to v original t minus 1/2 gt squared, and delta y is y minus y original. Original speed is 0, negative 5 times 3 squared. Therefore, negative y original is equal to negative 45. So y original is 45 meters. Now I need to solve for what is the final speed just before the pebble hits the water. And to do this, I choose equation number 2. V is v original minus gt. So v original is 0, negative 10 times 3 seconds. So velocity is negative 30 meter per second. Now it is asking for final speed. And if this is velocity with direction, then the speed without direction is just 30 meters per second. So there you have it.
Things get slightly more complicated when the motion involves up and down directions. In this case, we need to designate the certain direction as positive and the opposite one as negative. We usually take the direction of the original motion as positive. Therefore, the downward would be negative. Please note that acceleration due to gravity will always point in the same direction, which will always be downward, which makes the gravitational acceleration automatically negative. Let's see what happens to the velocity every second. 1 second passed, the velocity is going to decrease to 20 meters per second. Another second is going to take 10, and at the top of the path, the velocity would be momentarily 0. Another second, the velocity keep on decreasing to negative 10, negative 20, and negative 30. Please note that the up and down motion have a certain symmetry to it, such as the time to go up equals the time to come back down, or the acceleration during the entire motion is equal to g. The direction of the g remains the same. It is always downward, no matter which direction the object is moving.
Here's a question about up and down motion. An air rocket is launched straight upward with an initial speed of 35 meters per second. Okay, let's take the usual steps and have a list of given and unknowns. I'm going to use my coordinate axis again, and my rocket starts out at the origin. So this is y original. It's reached this intermediate point y1, which is unknown. Then it comes back to the original point, and I'll call this y2, which is again 0. And I know that when the rocket is first launched, it has an original speed of 35 meters per second. And sometimes students get confused about this and they think the initial speed must be 0. Well, the speed of the rocket was 0 when it was stationary, but when it started the motion, it starts with the fastest speed it could have, and that is its initial speed. Okay, now let's see what we need to solve for. First, we need to solve for what is its speed at the top of the path. So what is the speed here? I'll call it v1. So this is the position 1. Well, that is quite easy. v1 has to be 0 because if it doesn't have 0 speed, the rocket needs to keep climbing still. So v1 is 0. Now, even though its velocity is momentarily 0, the velocity did not stop changing. It's about to change again. So therefore, it is still accelerating, and this acceleration is g, just like we decided. And it's negative g because we know the downward direction is negative. That's how we designate it. Okay, now I need to solve for how high does it go. So I need to solve for the position y1. Okay, let's consult our list of equations. I need to solve for the final position. I know the original speed, VO 35, final speed is 0, and I know acceleration. I don't know the time, and I need to find the position. Well, it seems like the equation number 4 is a good match here because that is the only one with only one unknown for me. Okay, so let's try that. V squared is equal to V original squared minus 2g delta y. Now, what V squared? We are solving for the position 1, so this one must be V1 squared. And V1 squared is just nothing. V original is 35, so 35 squared minus 2 times 10, 20. And delta y is y minus y original, so y original is nothing, and this is just y1. Okay, so this means 20 y1 is equal to 35 squared, and 35 squared makes 1225. And when we solve both sides, y1 becomes 61.25 meters. All right, so that is our answer for part B. Now, part C, how long does it take to reach the ground? Now, I need to solve for time, and the two boundaries for my motion is y0, y0 to y2, okay? So I need to use the fact that the up and down motion has a symmetry here. In what way? For example, when it goes all the way up and down, the total displacement is going to be 0, right? y2 minus y0 is just nothing. So delta y equal to 0. And one more thing, when it goes back to the original position, it is going to have the same speed, but in the opposite direction. Therefore, the velocity v2 at the position 2 is going to be the negative of the original velocity, which would be negative 35 meters per second. And its acceleration is still negative g throughout this motion, and I need to solve for time for this case. Now, I can use either or one of these or both of these facts. I think I want to use the velocities, and I want to use this equation number 1 or equation number 2. Well, it could go both ways, so I'm going to go with equation number 2. So either one is a good choice. So equation number 2 goes v equals v original minus gt. Now, which v? I am solving for all the way to the position 2. Therefore, this must be v2, and this original velocity is v0. So v2 is negative 35, as we discussed. V original is 35, negative 10t. This means negative 10t is negative 70. Therefore, time is equal to 7 seconds. And that's the answer for part C. Here is the last question for this video lecture. An arrow is shot vertically up from the edge of a roof 25 meters above the ground. It strikes the ground 5 seconds later. Okay, so let's start as usual with the diagram. This is our y-axis. Now this time our motion starts here at y original of 25 meters with the original speed that is unknown. Then it goes to this intermediate point y1, which is unknown, but I know its speed. It's 0 there, right? Then it goes down to the ground at this final position y2, which is 0 meters, and its speed here or its velocity here, we don't know. Okay, so that's the situation. What else we know is the entire motion takes 5 seconds. The entire motion from position 0 to position 2 takes 5 seconds, and the acceleration is obviously g, and since we decided downward to be negative, it's going to be negative g like this. Okay, downward is negative. Alright, so let's use our list of equations as usual. So let's see, I need to solve for the initial speed. So checking this, initial speed at point 0, and I know the initial position, I know the final position, so I know the total displacement here, and I know the time, and I need to solve for velocity, so it looks like equation number 3 here. I can use equation number 3. So for part A, I will use delta y is equal to v original t minus gt squared over 2. Now, students usually get confused on a type of question. They think that they need to solve this in steps, like they have to go from 0 to position 1 first, then from position 1 to position 2. You don't have to do that. You can solve the problem between any two positions you want. Just make sure the time you are using corresponds with the positions you are dealing with. So the position I'm dealing with is y2 and y0. Okay, equal to v0 t minus 1/2 gt squared. So y2 is 0 and y0 is -25. So this is -25 equal to v original t minus 5. Oh, I do know what t is. T is 5. So this is just 5 minus 5 times 5 squared. Okay, so this means 5 v0 is equal to, rearranging, 125 minus 25, 100. So v0 is 20 meter per second, as you see. All right, there you have it. Okay, now part B, the maximum height it rises. Well, what do I know? I cannot use the time 5 seconds for this part of the question because that doesn't correspond with the 2 points of 0 to 1. So I do not know the time. What I do know is the speeds, and this means I should use equation number 4, right? Because I know original and final speeds and the acceleration, and I need to solve for delta y. So there we go. V squared is equal to V original squared minus 2g delta y. Now, which V are we talking about? From V0 to V1. So this is V1. Okay, V1 is 0, like we discussed earlier. At the top, it has to be 0. Equal to V original is 20, as we calculated earlier. So this is 400 minus 20 delta y. So if we rearrange, delta y becomes 20. Well, if you want to find Vy, you have to solve for it. So y1, y1 is then becomes 45 meters. So it is going to rise 20 meters higher, or the final position of 45 meters. And now finally, with what speed does it strike the ground? Okay, now I want to use the interval between position 0 and position 2 here because I know the time for it, and I want to use equation number 2. This is what seems easier to me at this stage. So I will go with V2, which is the final speed, equal to V original minus gt. So I'm solving between 0 to 2 points, therefore the time is 5 seconds for this interval. So v2 is unknown, equal to, original speed is 20, negative 10 times 5. So v2 becomes 20 minus 50 equal to negative 30 meters per second. And if you ask me, this makes perfect sense because at this stage velocity must be downward, and this is negative. So it is a good sign. So that's all for today. Thank you for listening.